Hey everyone, here is a quick video to help you with these 3 Khan Academy assignments on differential equations. Differential equations, wicked powerful, wicked cool. You just need to understand like how they are set up so that it has a little bit more meaning when you go to solve them. So you can describe many things in the real world as a relationship between rates of change and things that govern those rates of change. So here's an example. In one kind of chemical reaction, unconverted reactants, whatever they may be, change into converted reactions. Okay, that makes sense from chemistry. I think I know that. So if the fraction A of reactants that have been converted increases, so the conversion increases at a rate proportional to, and this is the important part, the product of the fraction that is converted and the fraction that is not converted. So product means multiplied. If you have a fraction and use the concept of like 1/4 that is converted, then the fraction that isn't converted is 3/4. If it was 1/7, then the unconverted would be 6/7. If it's some amount, then it's going to be 1 minus that fractional amount. All right? So if you go down here, we have the fraction A of reactants is changing, and that's the dA dt. Okay, so then we're saying it's directly proportional at a rate proportional to the product of that fraction and the unconverted fraction. So that is going to be A times 1 minus A with that constant of variation thrown in there. So it looks like this is our best candidate. Why again? Because there's the fraction. Think of it as like 1/3. And then times the fraction that is not yet converted, 1 minus 1/3 or 2/3. Okay? And so we'll get the sparkles, and we'll try the next one. See if you can do this. Pause me and do it on your own. The warming or cooling rate of a drink is proportional to the difference between the ambient temperature, T sub A, and the current temperature, T of the drink. Okay, is proportional to the difference. Difference means subtraction. Okay, and it's directly proportional. It's not inversely proportional. Okay, the rate of warming or cooling, and that is a rate, so it's going to be the change in temperature, not the temperature, but the change in temperature. So right there, we only have A or D as our options. It looks to me like A is the best candidate because it's proportional to the difference, the subtraction between the ambient and the regular temperature. So once you see these, they're pretty easy. Hopefully you can build some confidence. The learning rate for new skills, here's the learning curve, is proportional to the difference between the maximum potential for learning that skill. Okay, the difference again is subtraction between the most you can possibly learn and the amount of skill already learned. This is totally what they call on the learning curve. All right, which equation describes this relationship? All right, well again, you're going to have a constant of variation in all of these, and then the difference between the maximum and the amount learned is just the difference between M and L. Looks like that. Oop, that's not it because we want the rate of change. Whoop, that's not it either. It's going to be D. It's the rate of change then with a constant times that difference there. All right? So then we've got the final one is the learning rate for new skills is proportional to the difference between the maximum potential for that learning skill and M and the amount of the skill already learned. So which equation best describes this relationship? Whoops. Oh, sorry, done that one. I needed the next question. Sorry, the vacuuming outside the door. That's hilarious. A puppy gains weight W at a rate approximately inversely proportional to its age T in months. So inversely proportional, this is going to go below in the denominator. That's like what the concept of inverse is. 1 over that thing. That's why that, like x to the minus 1 on your calculator is a symbol for inverse operation. Okay? So 1 over T. And then you have to get the constant of variation. That can go anywhere. It can go like alongside it, but of course when it's multiplying, you're going to put it in the numerator. So we're looking for K over T, and there it is. dW dt is just going to be K over T. All right. So now, moving on to the next tab, we've got verifying solutions. Hopefully we've done this in class. This is fairly straightforward. I've teed this up because it's so hard to write. Here's our original, that's our function, okay? And we want to say that the derivative of that function is in somehow relationship to the original function in this way. So if I take the derivative, I take and bring that out front. It's my chain rule. I get 6. Then I kick it down a notch to go to the second power. That's then the ln of x. Then you have to take the derivative of the inside for the chain rule. So I'll simplify this by putting it over x and then just getting rid of this. And now I have to ask myself, is that the same as this thing here? Well, if I cancel an ln of x, I'm going to have 3 times 2, which is 6 ln of x to the second, and that will be over x. So I'm going to say yes, that is verified. Okay? So there'll be more like that. I think you know how to do those. Just to get to the end of this, here is a slope field question. Look at that slope field. It's done out all the way out to 10. Here are your options. Before we pick an option, let's look at this. What I would see is that every time x and y are equal, I get a slope of 0. So the way you're going to get x and y being equal is either x minus y or y minus x. When they're both negative, you're going to get them canceling out. When they're both positive, either way, you're going to get them canceling out. But then look at this. If it's 2, 1 and 3, 2, I get a positive 1. So it looks to me like 3 minus 2 is a slope of positive 1. 4 minus 3 would give me a slope of positive 1. So I'm guessing that this is going to be something like y prime equals x minus y. Y dy dx is x minus y right there. Let's just double check. If I go out here to this spot right here, 4 minus 5 is negative 1. That looks good. Okay, 4 minus 5. Yep. So there we go. Maybe we can check and see. In drawing a slope field for this differential equation, I would place short line segments at selected points on the xy plane. Yep, got that. At the point 0, 1, I would draw a segment of slope. Okay, plug in 0, plug in 1. I'm going to get negative 3, negative 3. Here, when I plug in 1, negative 1, I would get 2 minus a minus 3. 2 plus 3, I'm going to get 5. When I put in 2, negative 2 here, I'm going to get 4 minus a minus 6. I'm going to get 10. Lots of opportunities to make silly mistakes. Hope I haven't done that. There we go. That's all for today's show, folks. Good luck with the homework.